Hello everyone. My name is Masaaki Kondo of Keio University and RIKEN Center for Computational Science. I am in charge of the System Architecture track for ISC 2021 Invited Program. I'm going to briefly talk about the overview of invited sessions in the System Architecture track. In this track, we have 4 focus sessions listed here. We had a wonderful lineup. The first one is about new memory technologies, chaired by John Sharp. The second is containers in HPC, chaired by Christian Knight. The next one is about RISC-V. RISC-V as next generation HPC component, chaired by Christy Asanobi. And finally, about exascale systems, chaired by Anton Liu. All the chairs are very expert of the corresponding area. The topics are very broad, and I cannot go into details for each of the sessions, but I'd like to briefly introduce the contents of these sessions. First is new memory technologies. Yesterday's storage technology is based on POSIX 5 I/O interface that needs seeking the location of bytes to read and write. On the other hand, today's storage subsystem is almost random access memory, where any location can be directly accessed with low latency. This change has been made by non-volatile memory technologies, which are rapidly supplanting disks and tapes. One of the important trends is that non-volatile memory performance is starting to match performance of conventional volatile memories, especially in data read performance. And this will break distinction between storage and memory for future HPC and data center architectures. This special session will discuss the interesting questions. For example, what are driving requirements in HPC and data centers for the next decade? How will both volatile and non-volatile memory technologies evolve to meet those requirements? How will the confluence of those two technologies change future system architectures? You may find a part of answers of these questions in this special session. Next is containers in HPC. Container technology is gaining traction in HPC community because it can provide flexibility, ease of deployment, portability, interoperability, reproducibility, and so on and so forth. It will be indispensable for future complex software stacks, especially associated with highly heterogeneous HPC architectures. It is believed that one of the challenges of containers in HPC is their performance overhead and scalability. However, in some cases, performance in container is comparable to the native execution or even exceeding native installation by specializing the software stack. In this special session, the speakers will discuss several topics such as why containers are essential to HPC, how to approach it, how to get started easily, as well as how users will success in using container images. Next one is RISC-V for high-performance computing. RISC-V is fifth generation of RISC architecture developed at UC Berkeley. It's an open, simple, modular, clean state design, and stable ISA. One of the very important characteristics of RISC-V is its extensibility or ability to enable specialization. One of the ways to improve performance in post-Moore's supercomputers would be applying domain-specific architectures or accelerators by extending ordinary processors. RISC-V is very suitable for domain-specific architectures because it offers fine-grained communication between general-purpose processing cores and accelerators. There have been many efforts of developing domain-specific architectures with RISC-V in academia and industry. We will see interesting and state-of-the-art examples of such architectures from the speakers of this special session. Finally, about exascale systems. This chart shows the US DOE roadmap of exascale systems, as well as that of the Japanese flagship machine. Recently, many of the exascale systems have been launched or unveiled. In the next couple of years, we will see a number of such systems, and we are now in a very exciting period. But I think it's time to think about a post-exascale decade. Due to the end of Moore's law, we need to have significantly different approaches to how we do computing. Hardware landscape will be more diverse and uncertain. What will be most critical technical challenges in next decade of HPC architectures, and what kind of technology will be a key for developing post-exascale systems? We'll have an interesting and exciting discussion about these questions in this invited session. Please look forward to the invited program of ISC 2021. Thank you.